All right, I just wanted to finish out these last two examples from last week's notes. So if you wanted to watch through those, you can. The previous recording didn't work, so I'm going to try this again. Okay, so again, as we were talking on Thursday, right, we were just discussing this idea of finding a particular solution. So again, that means that after we get our general solution, we're just trying to find out what C value is going to make it go through this specific solution, right, this specific point. So for example, here we know that it's going to go through 1, 2, right? But of course, everything, the first step is always the same. We want to separate our variables, so that's no different. So we've got our dy dx equals xy cubed. So separate, so we're going to move my y cubed over. So I'll divide that over. We've got dy over y cubed equals x dx. Right. Step 2, now we want to integrate. Be careful here because this is 1 over y cubed dy. That is not going to be a natural log, right? I still have people doing that. Remember, the only time it's natural log is if it's 1 over y, 1 over x to the first. This is to the third. So we want to think of this as y to the negative 3, right? So integrate the other side. Okay, so we've got y to the negative 2 divided by negative 2. And then over here on the other side, we've got 1/2 x squared plus c. Now, let's before we do anything else, let's do real quick. We can easily simplify this a little bit, right? Because I can multiply everything here by a negative 2. And so the nice thing about that is that this is now going to be y to the negative 2 equals negative x squared. And when I multiply c times negative 2, that's just going to give me some new c. Right? So that's going to be a little bit simpler then. It's not that we couldn't have plugged into the way it was. This just makes our life easier. We're always looking for ways to make our algebra a little simpler, right? So then we've separated, we've integrated. So our next step is going to typically be to isolate that y. But I'm actually going to pause here, and I'm going to solve for c. So again, we talked about this on Thursday, that sometimes it's actually easier to solve for the c before we isolate. So let's plug that in. So we've got 2 to the negative 2 equals negative 1 squared. Right? So 2 to the negative 2 is 1/4. And be careful because that square is only on the 1. The negative is out in front. So we're squaring the 1 times negative. So negative 1. So we're going to add the 1 to the other side. C is 5/4. Okay. Now that I have C, now let's go through and isolate. So I'm going to go ahead now. I've got y to the negative 2 equals negative x squared plus 5/4. Right? And so last step then is I can raise both sides to the negative 2. Or if you don't like that, you could write this as 1 over y squared equals negative x squared plus 5/4, if you prefer to do it that way. And then essentially, right, we're multiplying the y squared to the other side and then dividing this over. So we end up with 1 over negative x squared plus 5/4 equals y squared. And so when I square root, technically I'm going to have plus or minus, right? But this is where we have to then also think about, okay, it's not going to be both, right? It has to be a function that's passing through the point 1, 2. So if I think about, okay, when I plug in the point 1, 2, right? So if I plug 1 in, this is going to be negative 1 squared plus 5/4, right? So that's going to be 1 over 1/4, which is 4. So I've got the square root of 4. Obviously, it can't be plus or minus because I know it has to pass through positive 2. So I need to make sure then I'm only picking the positive, right? So my final answer should not have the plus or minus because I've chosen the one that's going to pass through the point 1, 2. Okay? All right, one more. If you're interested, find the equation of the curve that passes through 1, 3, has a slope of this at any point x, y. Okay, so this time they didn't actually write dy dx, they just said it has a slope of, so we're going to write that out first. So step one, right, we're going to separate those variables. If I don't show that separation, I'm not going to get the credit. So I'll multiply the dx to the other side, divide the y over. So I get dy over y equals dx over x squared. All right, so step two, now I can integrate. Again, if it's helpful, write the dy off to the side, right? This is 1 over x squared dx. So on my left-hand side, I am getting the natural log of absolute value of y. But over here on the other side, right, I'm actually integrating x to the negative 2, which is x to the negative 1 divided by negative 1. Right? So just be careful of that. Again, I'm going to pause, and we're actually going to go ahead and solve for c now. It's going to be a little bit cleaner. Not a lot this time, but a little bit. So I've got the natural log of 3 equals negative 1 to the negative 1. So c this time turns out to just be natural log of 3. Absolute value of 3 is 3. And then I'm going to add the 1 over. Now be careful there because you don't want to combine that 3 and that 1, right? So you're taking the natural log of 3 plus 1. So there's your c value. Okay, so my final equation then. So now to isolate, I've got the natural log of y equals negative x to the negative 1 plus the natural log of 3 plus 1. Right? And so then if I solve that, y is going to be plus or minus e to the negative x to the negative 1 plus the natural log of 3 plus 1. And again, we've got to decide, is it the plus or the minus? So if I think about when I plug in the 0.13, right? So if I need to decide, if I plug in the 0.1, so if I plug 1 in, then notice that up top here, this is going to cancel, right? And then I'm going to e to the natural log of 3, which would just be 3. But I can't have both plus and minus because I wanted it to be positive 3, right? So my final equation then is y equals positive e to the negative, and if you want to write this 1 over x instead of x to the negative 1, you certainly can, plus the natural log of 3 plus 1, okay? And that's technically correct. Again, this is where if you preferred to simplify some things, right, you could say this is e to the negative 1 over x times e to the natural log of 3 times e to the 1, right, and decide, hey, well, e to the natural log of 3, that's just 3. So I guess I could say this is 3 e to the negative 1 over x, and then I'm actually just going to leave the plus 1 up there in the top, right? So that would be another way to write it. But this is certainly acceptable, right? Any of those are going to work. Okay? There you go.